All right, welcome everybody to Standing for Truth. My name is Donny Budinsky, and I am your host for today's program. I am thrilled to have Michael J. Oard with me here for another valuable presentation. And as always, it is a privilege to have Mike here to help me uphold the truth of biblical creation. He is an excellent researcher and has blessed this ministry with so many fantastic presentations. Now, these presentations include the rapid formation of caves, the receding floodwaters, the Ice Age, answering challenges and refuting objections, the Green River Formation, flood boundaries, the Missoula Flood, ice cores, and more. And so there's a lot of content and material for you to check out and hopefully be edified by. And so I do encourage people to check the description box of this video for links to the past programs here with Mike. And if you go to the Standing for Truth Ministries website under guests, you'll find Mike's presentation and work there as well. Now, today's program focuses on the geology of Mars and evidence for the Genesis flood. And I'm excited for this presentation. So before we get into it, Mike, I just want to give you a formal introduction for anybody who might be unfamiliar with you. And so Michael has a master's science degree in atmospheric science from the University of Washington and is now retired after working as a meteorologist with the U.S. National Weather Service for 30 years. He has researched and speaks on the compelling evidence for Noah's flood and the ice age that followed, and how the incredible woolly mammoth connects to biblical history. Michael has published many papers in his field in widely recognized journals and has written An Ice Age Caused by the Genesis Flood, Ancient Ice Ages, or Gigantic Submarine Landslides, the Missoula Flood Controversy, and the Genesis Flood, and the Frozen Record. He is also author of Frozen in Time, The Weather Book, and Life in the Great Ice Age. You can find this introduction and more from Mike at creation.com. And so, Mike, it's great to have you. I hope you've been well. And tell us, how are you doing today?
I'm doing well.
Great. Well, I'm excited for this presentation. Again, for anybody just joining us, we are focusing on the geology of Mars and evidence for the Genesis flood. So it's an exciting topic. After Mike's presentation here, which I'm going to give him the floor in a second, we will be doing a live audience Q&A. So I've got my own questions for Mike, and then we also want to interact and engage with your questions. So please, if you do have a question related to the topic or flood geology in general, just make sure you're tagging me, send those in, and we'll have some fun interacting with them. Mike, I'm going to hand it over to you. I've got your slides up on the screen, brother, and the floor is all yours.
Okay, thank you. My title is, Did the Floods on Mars Occur During the Genesis Flood? Us creation scientists are fond of telling the secular scientists that they can believe in gigantic floods on Mars that has no liquid water, and yet they can't understand why there's a global flood on Earth that have 70% covered by water. But what about these floods on Mars? Were there really floods on Mars? And what do they mean? How did they start? Yeah, it is a conundrum for actually both sides, creation scientists and secular scientists. Anyway, we need to talk a little bit about Mars. There's quite a few mysterious features. There's a crustal dichotomy. In other words, the northern hemisphere of Mars is about 5 to 6 kilometers lower than the southern hemisphere. Also, at the poles, there's 2 to 4 kilometer thick polar ice caps. And in the mid-latitudes, there's ubiquitous ice, several hundred meters thick. And there's been enormous volcanism on Mars. In fact, it's the largest volcano in the solar system, in Olympic Mons. I think it's 21 kilometers high. Then there's the the deepest canyon in the solar system, Valles Marineris. By the way, these terms are in Latin. And it had a past magnetic field, and there were catastrophic floods. But here's a map color-coded for Mars. And you can see the blues are deep. The lowest area on Mars is the Hellas crater, 2,400 kilometers in diameter. And 3 other impact craters of note are this one here, this one down here, and there's one in this area right in here. And here are the volcanoes, color-coded very high. This one's Olympic Mons over here. And here's 3 of them in a line here. And then we have Valles Marineris. I think it's, if I recall right, 4,000 kilometers long. It's about over 10 kilometers deep in places. And then up here, you see that the polar ice cap in the North Pole, it's got a very interesting structure. And on the South Pole, it's similar. So that's the kind of the topography of Mars. You can see it's full of craters of various sizes. And this is a view of the polar ice caps, which are layers of dust and ice, generally 10 to 80 meters vertical distance. And the impact craters of
I think Mike might have froze on my end.
about 500 kilometers.
Mike, it looks like you're back. You just froze up for maybe the last 5 seconds. So if there was a point you wanted to reiterate, but you are back, you're coming in clear now.
Okay. I'll go back to the previous slide. Did they see this slide?
Yeah, I think that was roughly where you froze up.
Okay. Yeah, that's the polar layered deposits with dust bands of various thicknesses, separated about 10 to 80 vertical meters. And then some impact craters of note. Utopia Planitia, the largest, and on the right, the diameter of the impactor, 500 kilometers in diameter, greater than. Hellas, that's about 500 kilometer diameter impactor. They assume the impactor hit at the escape velocity, which is an assumption on their part, and that may not be true. But regardless, it's the kinetic energy, which is a mass and the velocity squared, that creates the crater. And if the velocity is more, the mass could be less, and the mass would have a smaller diameter. Anyway, you can see the other 2, Sidus and Argyre. I can't pronounce that. And so those are some ones of note. And here's a little bit of a better close-up, the volcanic area. This volcanic area in general is about 10 kilometers high. And here is 3 main volcanoes right in here. Here's a little volcano that it's more spread out. And this is Olympic Mons. You can tell the volcanoes from the impact craters, I might add. And here is this famous Valles Marineris right in here. It's 10 kilometers deep. And it starts high from 10 kilometers and drops down to below the 0 level. And you see all these interesting features out in here, which are flow features. I'll get into that. This right here, that is the largest outflow channel on Mars, which I'll talk about soon. And Mars has a mysterious crustal magnetism, a remnant of when it had a strong magnetism. And it's kind of weird. They're like stripes, like we have in the ocean. The stripes we have are really weak compared to these. These are much stronger. And these are east-west, while the ones in the ocean are mostly north-south. And the origin of those stripes, I might add, in the ocean is a bit controversial because they're mainly alternations in intensity, magnetic intensity, and not direction. And this is, and these stripes are much stronger, and no one knows the cause of them, except that you had to have a magnetic field to produce them that has since decayed. Now, some areas, it's interesting, don't have much of a magnetic field, like the high volcanoes, Valles Marineris, Utopia Planitia, Elysium Mons, another volcano, Hellas Crater. So that's rather interesting. And I think that's going to be key to determining what caused the floods on Mars and timing it. Anyway, they always date Mars into billions of years. And there is evidence for a young age. And now the obliquity of Mars, that's the tilt of Mars, varies a lot. And it can go as low as 45 degrees to about 15 degrees. So at high obliquity, you should have tropical glaciation. But there's little or no evidence of tropical glaciation, which should occur at high obliquity, which occurred quite a few times. The last time maybe just a few million years ago within the secular time scale. The mid-latitude ice, if it was deposited over millions of years, billions of years even, should have a fair amount of dust. But it's pretty clean, and this is based on impact craters that have hit that. You see nice white ice and not dirty ice. Also, Mars volcanism occurred throughout its history. Why is Mars still active? It should be stone cold dead if it was billions of years old. Also, you have minerals on the surface that weather quickly. Even in Mars's thin atmosphere is about 6 millibars. Earth's atmosphere in comparison is 1,000 millibars approximately. Anyway, the olivine, pyroxene, and feldspar are abundant on the surface. These easily weather, indicating that it's younger than they think. And this is an old Mariner 9 picture of a valley. There's lots of valleys that they've found on Mars, and these look like river valleys with tributaries, which I believe they were. They're dry now. Anyway, valley networks. There's a lot of mysterious features with these. First of all, there's tens of thousands of them. They're practically all in the southern highlands, in the southern hemisphere, mainly around the equator and 40 degrees south. They're average about 100 to 200 kilometers long, 50 to 350 meters deep, and 500 meters to about 20 kilometers wide. And a lot of them mostly start full-sized. They don't start by a narrow valley like on Earth and then expand as you go downstream. And some of them are from breached lakes, especially from impact craters. They have a patchy distribution, and the drainage profile is said to be immature. In other words, it's not a nice concave up slope. It's a concave a lot of times, as if they form quickly and they haven't been enough water to carve a concave feature like you'd have on Earth. And here's a real interesting tadpole-shaped feature where um, a crater breached at one point and formed this valley right here. And then here's one in it's just forgot the crater name on this. This is one of the where we sent a probe to look at this delta. Anyway, you see a valley coming into this crater and then forming a delta. There's lots of deltas on Mars. Hey, again, indicating the action of water. And they date these features by the amount of impact craters on them and their size, I might add. So you can see over here, lots of little impact craters. And so they would date that a little older than other parts. I'll get into that a little more. Now, here's the famous Cassie Vallis. It's about 2,000 kilometers long, about I think 250 meters deep, 80 kilometers, no, more than that, maybe a couple hundred kilometers wide. But anyway, take a look at some of these features in here. You have streamlined islands. I mean, these are features similar to the Lake Missoula flood features in eastern Washington, and that's the largest outflow channel of all. And this, to fill this up, it likely formed in one flood, and it implies maybe 10 to 100 times the volume of water in the Lake Missoula flood, which is 10 times the flow of all the rivers in the world. So we're not talking about little tiny floods. We're talking about monster floods. And it ended up going into Cris Planitia, which is a huge impact crater. And here are some other valleys you see along here. Okay. There's a lot of outflow channel mysteries. Cassie Vallis, I gave you the dimensions of it. There they are, 400 kilometers across, 2.5 kilometers deep, and about 2,000 kilometers long. 10 to 100 times the flow of the Lake Missoula flood. And often they start full-sized and from below the ground. This has really caused a lot of consternation among scientists. And most of these end up flowing into the northern plains, mainly Cris Planitia. And here is a poor picture of the Lake Missoula flood in northwest U.S. The Cordilleran ice sheet blocked the Clark Fork River in Idaho, created a 2,000-foot deep lake in the valleys of western Montana. And it broke through, eventually, filled up Glacial Lake Columbia that overtopped a ridge and spread down these red areas you see. And then forming a huge lake, 800 feet deep around the Pasco area, finally making it through the Columbia Gorge 1,000 feet deep, 80 miles an hour flow, backwashed up the Willamette Valley to Eugene, Oregon, and finally out to the Pacific Ocean. Here's a satellite picture of it. Which shows up because the silt on top, which is about 20 to 80 meters average thickness, or feet, I should say, was eroded down to the black basalt. So you see a pattern of a diverging and converging flow from the Lake Missoula flood. And these are some pictures from the Lake Missoula flood showing some of the lens-shaped erosional remnants like we see in Cassie Vallis. So it's pretty strong evidence that it was from a huge flood. But not all secular geologists believe it. There's several of them that believe that they were formed by lava flows, but that doesn't seem very likely to me and so many others. And here's another feature from the Lake Missoula flood, 300-foot waterfall with plunge pools, at dry falls. And gravel bars like this from the Lake Missoula flood out of the middle of nowhere. And then forming these huge deltas like where it left the Columbia Gorge between Washington and Oregon from the Portland Delta, over 200 feet thick of gravel. And by the way, when I talk about gravel, this is coarse gravel that can be up to big boulders through here. And then finally, after it deposited this delta, the Columbia River channelized and cut the main channel through this at the end of the flood, when the flood channel and the Columbia River just takes advantage of that channel. Anyway, they date by crater distribution. The more the craters on a surface, the older it is. And so they divided Mars up into 4 main periods. The pre-Noachian, before 4.1 billion years, GA means billions of years. The Noachian. Well, that gives you kind of a hint of what they're thinking about the Mars having a huge flood during that period about 4 billion years ago. Then the Hesperian, which is not a very long time, 3.7 to 3 billion years, and then the Amazonian, 3 billion to the present. Most of the activity that they talk about occurred in the Noachian and the Hesperian. Anyway, we'll get into that. Dating deductions. They believe the Noachian was warm and wet with degraded craters. But it's interesting that even though that is the case, there are not very many valley networks in the Noachian. They're mainly in the late Noachian and the Hesperian, and even in the Amazonian. Outflow channels, which you'd expect in the wet Noachian, are actually in the Hesperian. That's when the major outflow channels occurred. So there's a lot of contradictory pieces of data in this, and partly I think it's because of their crater dating system is not very accurate. And why isn't it very accurate? Because how large of an area do you need? And that may depend on a lot of things, how many craters. So it could be a lot of bias based on the size of the area. Some craters are buried or eroded. Also, if you hit impacts hit a surface too often, it saturates it, and so you miss a lot of them. And there's problems of numerous secondary impacts. When a big impact hits, it blasts up maybe 100,000 smaller pieces of rock that come down and form little tiny craters. They would mostly be small, but a couple kilometers or less. And there's some contradictory events. Early Mars climate is supposed to be warm and wet, but the valley networks, like I said, are late Noachian and even in the Hesperian, and outflow channels are in the Hesperian. This is reinforcing a point I've already made. But they also, both of them, valley networks, VNs, and outflow channels also occur in the Amazonian when it's supposed to be dry like it is today. I mean, with water totally frozen. So this brings up a lot of issues. And there's questionable timing of the Tharsis volcanism, those huge volcanoes that went off. And the climate models, they run a lot of climate models and say there should never have been any liquid water, especially early in their history. And this is two graphs, but pay attention to mainly the red one. This is the solar luminosity with age. Because of the faint young sun, billions of years ago, less sunlight occurred. So 4 billion years ago, you only had 7.75 or 75% of the sunlight we have today. And it didn't get up to till the present, till recently. In fact, you might ask, why weren't there massive ice ages throughout most of Earth history. Well, there were ancient ice ages, clear to over 2 billion years, but I think these are caused by gigantic submarine landslides during the flood, and I have a book on that topic. So Earth should have been glaciated, but Mars receives 40% less sunlight than Earth, and if you add this faint young sun effect, billions of years ago, when these floods of Mars are supposed to occur, they had about 25% of the sunlight we have here on Earth. So why were there floods on Mars? Well, first of all, maybe they didn't occur that long ago to the point where there wasn't any faint young sun. And I'll get into more of that later. There's also a few mysteries. This is all I'm going to say on these. There's also another geomorphological feature on Mars, which is kind of mysterious. There's these gullies. These are meters to a few tens of meters wide, hundreds of meters long, and up to that should be 100 meters wide, and up to 7 deep. No. This one should be deep. This one should be wide. I got it all messed up. Up to 7 kilometers long. Anyway, they're very young, and they've been observed forming by satellites today. Is this due to liquid water forming these? Don't know. They start on high areas. So I think the opinion is going towards there's some kind of dry debris flow. But anyway, it's a minor mystery, and that's all I'm going to say. But there's some major flood questions. Were the flood features eroded by water or not? I've addressed that already. There's a group led by Leverington that believes they're lava flows, but there's not very few people who believe it because there's so many features that indicate water and things that lava couldn't do. Like if lava eroded Cassie Vallis, where is the pile of lava that would pile up at the end? You don't find it. And then there's a question of were valley networks carved from overland flow or groundwater? What makes them think that groundwater could be part of it? Well, they have amphitheater-like features in some of these valley networks. And were the floods catastrophic or 10 to 100 times the flow of the Lake Missoula flood, or were they much more minor and more often? So those are some major questions that we all have. And there's other ones. Where did the water come from? How much water is needed? Where did the water go? And then how was it glaciated? How did you form the ice in the mid-latitudes and those 2 to 4 kilometer thick ice caps on the poles? Anyway, I think from a creationist point of view, biblical point of view, I've come to believe the day 4 cratering hypothesis from Danny Faulkner, PhD in astronomy, from Answers in Genesis. And he's worked out from the moon that most impacts, he believes, are on day 4. And all the bodies of the solar system were made from pre-existing material, and part of the making was due to planetesimals striking the surface at the very end, causing these. Now, this did not happen on Earth because Earth was created before day 4. So the majority of impacts were from making of the solar system bodies on day 4. And but then there's some large craters that are superimposed on many of the small to medium sized, like the large basalt filled craters on the moon from flood basalts. He attributes those to the Genesis flood, And I was not signed in on that idea. I like to investigate things in depth, and I had to think about that and did not accept it until I studied the craters on Mars, which I can time better uh, because of the magnetic field that decay out, which I'll get into. And he believed that the impacts during the flood were focused, a focused stream that only hit the moon and Earth. And I'll show that it went out to at least Mars, and it maybe hit other bodies of the solar system, but we don't know. So all the solid bodies of the solar system are just filled with craters, impact craters, except if they've been resurfaced by lava or debris. Now, this is the far side of the moon, has many of those day 4 craters, and very few large craters on the far side. They're practically all on the near side, indicating that as the moon turns in 28 days, the impacting hit mainly one side. It was a quick impacting of large craters. Some of these, the diameters of some of these are over 1,000 kilometers in diameter. Anyway, that magnetic fields are caused by electrons that move in the liquid core, but they decay with time. On the Earth, they're decaying with a half-life of 1,470 years from Dr. Russ Humphreys. So Mars had an early magnetic field. And like I pointed out, a number of these features, there's no magnetic field through them. In other words, when the impacts hit the surface that probably had these stripes on it, it destroyed them. And if the magnetic field was still in operation, it would reform from the liquid crater fill. And same with volcanism from the liquid lava. But it didn't, or actually very little, as I'll show. And so we can time these big craters and these events. Anyway, we find a lack of magnetism in the large craters and volcanic areas. There is some, but not much. Medium to large impacts and volcanism actually will destroy crustal magnetism. That's the key. And they didn't, and they would reform if the magnetic field was still strong. So, what magnetism you do have, you can time it by the decay of the magnetic field on Mars. So they must have started with a strong magnetic field, but there's none now. They believe the half-life of the magnetic field is about several 100 million years. But based on just straight electromagnetism, Russ Humphreys has calculated a half-life of the magnetic field is 308 years on Mars. Therefore, large impacts and volcanism occurred much later than the creation event. So, here is a plot of the half-lives of Mars craters. At creation, there's a maximum amount, and where you have a lot of craters, and these the magnetic field goes right through those craters, superimposed on them. And the half-life like this. So the flood was about 1,600 years ago after creation. 1,600 years after creation, somewhere in here. So there was a little magnetic field still in existence at the time of the flood on Mars. And that we can use to estimate when some of the impacts, especially the larger ones, hit Mars. So here's the maximum magnetism in the 4 impact craters I showed you. It's generally pretty close in amperes per meter. And by the way, this is probably a minimum because post-impact features would and hydrothermal flows would tend to weaken the magnetic field some. So these would really be a little stronger right after the impact. And this little bit of magnetism indicates that it was just the magnetic field hadn't quite decayed, but it was still there, which puts it down in this region right in here, which is about the time of the Genesis flood. So that brings up the question, well, did impacts have a part in the Genesis flood? Which I believe they did. And you can find a whole article on it on my website on it. It might be hard to find because my webmaster, my son, couldn't change the header, so it's under what's called resources. Yeah, 21,000 word essay on flood impacts, and it could be a submodel of catastrophic plate tectonics. I haven't quite gelled those together yet. I believe in both now. So this times those big impacts as the time of the flood. And here's kind of large and some small to medium craters occur about the time of the Genesis flood, consistent with the day 4 cratering hypothesis. And for my study on Mars, that's when I accepted the day 4 cratering hypothesis. So the focused impacts not only hit Earth and the moon, but Mars also. Now, what do impacts do as far as causing floods? Well, here is one article, Turbay et al., 2020. This is what they say on one impact. And this is only a 100 kilometer diameter impactor. Remember, some of the big ones had maybe 500 kilometer diameter impactor. Anyway, a 100 kilometer one produces a crater about 600 kilometers in diameter. It will cause a warm climate on Mars for tens of years. And it would cause a hot crusted mantle, melting a huge amount of water that was in the subsurface as ice. It would cause intense hot rain for about 12 Mars years, which is about each year. Mars years is 1.88 times an Earth year, and produce 58 meters of what's called gel. Gel is global equivalent layer. In other words, if you spread out the water all over the surface of Mars, it'd be 58 meters deep. That's the measure they usually use for the water on Mars. That's a lot of water, 58 meters average over the whole surface. That's one impactor. And of course, it'll be hot, but it'll cool and the rain will change to snow. And this is only from one very large impact. But what if all the big ones and many small to medium impacts occurred over weeks, up to maybe months? You'd have a monstrous amount of heat, monstrous amount of water that would be produced, liquid water, and you can have floods. But precisely how you had those floods is a bit of a mystery still. Also, I believe that the impacts caused the volcanism. Because the Tharsis and Elysium areas also show little or no magnetism. So they occurred about the same time, and probably caused by impacts, even though that is speculative, I'd say. Now, it's been said that volcanoes give off a lot of water vapor. It's estimated that Tharsis volcanism can add 1.5 bars of CO2. And by the way, you need a thicker atmosphere, which you can get in this model, and 120 gel of H2O. But unfortunately, a lot of that water is locked up into the volcanic debris and the volcanic products. it's more likely that the combined effect of these volcanoes going off would only add 15 gel. Remember, one impact of 100-kilometer diameters can create 58 gel. So it's the impacting that I believe is the major factor that causes the liquid water on Mars, and the volcanism adds some. But volcanism adds a lot of particles and can explain other features on Mars, which I will not get into. Anyway, I believe that impacts and volcanism cause the Mars flood. They add heat and vaporize ice. Volcanism adds a little water vapor and carbon dioxide and sulfur dioxide. Telescope to days, weeks, and possibly up to years. Like started as rain, but it's going to cool off pretty fast. So it's all going to change to snow. And so a lot of snow would fall at mid-latitudes and pile up as ice sheets at the poles. And how much water is needed? Well, this is still a subject of research. Some say each large impact produces only 10 to 20 meters of gel, not 58, as Turbay et al. Had said. The ice caps in the mid-latitude ice total is 20 to 40 meters of gel. So the needed water for that has been estimated to 3,000 to 5,000 meters gel. So you can see a wide range, and these are a lot of times the results of models that they run. And all models are flawed, of course, because you can't get the variables exactly right. And you might miss some variables that are key. Anyway, I think, and some secular scientists go along with this, that multiple 100 meters gel is probably good enough. And multiple large impacts can easily produce that much water on Mars. So what is the precise origin of the valley networks? Well, I would say it's probably heavy precipitation for years as the liquid water in the atmosphere rains out. And some valley networks are from breached lakes, lakes and craters, for instance. And I believe the reason you find most of the valley networks in the southern highlands is because you'd have upslope flow at times from the low northern, the lowlands up the highlands, and that's kind of a windward effect that would cause more precipitation in the higher areas due to the crustal dichotomy and convection, resulting in patchy valley networks and an immature drainage. Immature because it was a brief episode, and they're patchy because the huge convective clouds were patchy due to upslope flow. And the origin of the outflow channels are very interesting. I believe, and by the way, I'm not the only one who believes it. I think a number of secular scientists believe the same thing. The outflow channels were from breached lakes or craters that started underground first and then came up in what's called a chaos area. These are wide areas that indicate where the water came up and where it's collapsed. The surface has collapsed into interesting shape features, sometimes 7 kilometers of a collapse. The water wasn't in the ground there because the permeability wouldn't be great enough to cause a huge flood, because you have to have that water all at once. So it's believed, Michael Carr especially, I thought he had some pretty good ideas. From many deep lakes in Valles Marineris. In other words, this valley network was filled up. There's a lot of evidence for sediments in Valles Marineris. And a lot of these outflow channels are close to Valles Marineris, and so the floods would start under the ground, and then they'd issue up in a chaos area below the surface with the massive amount of water from breached lakes. Here's a quote from Carr's book. Such a high-standing lake, as in Valles Marineris, and accompanying water table would have provided the high hydrostatic pressures needed to account for the high discharges estimated for the channels that start in the chaos-filled depressions to the east and north of the canyons. When they say canyons, Valles Marineris is a series of canyons, not just one continuous canyon, but a series of them, most of them connected. And the canyons are 3 to 5 kilometers below the postulated lake level. I think he's onto something, because the outflow channels a lot of times start from near Valles Marineris. If it's blocked over in this area, it form a lake in here 6-10 kilometers deep, and here it breached under the surface, almost full sized to start Cassie Valles. And here is other ones that have started this, and out in here. And you can see the flow features out in Chris Planitia, which is believed to be a gigantic impact crater. You can see the outflow channel material, and the streamlining continues way out in here. And so it filled up these low areas. Then where did the water go? Well, first of all, calculations show very little is lost to space, even over billions of years. Well, it's obvious, I believe, that it absorbed into the ground, which was warm from the impacting. And then water is incorporated into a lot of hydrated minerals which are on Mars. And so that's how it would disappear. It disappeared mainly in the northern lowlands. So what is the meaning of all this, of Mars floods, to biblical Earth history? Well, day 4 cratering hypothesis can explain the Mars floods. It occurred about the time of the Genesis flood. Implies impacts also occurred on Earth during the Genesis flood. And there's about 200 confirmed impacts on Earth. In fact, there's more than that, and these are practically all from continental areas. But the criterion for an impact on Earth is very stringent. And I believe they miss a lot. As a result, there's a lot of possible impact craters on Earth. And also, you don't find hardly any impacts on the ocean bottom. Mainly, that could be due to catastrophic plate tectonics that where the old ocean crust subducted. Also, you don't know about the impacts on Greenland and Antarctica, and Eastern Asia is poorly represented. So, and I think because of the stringent requirements, some of those large cratonic basins that are very circular looking, like the Williston Basin, are impact craters. And so there's probably evidence for, I've tried to estimate this. So I think there's evidence you could have had about 1,000 impact craters during the flood. And they go back clear into the early Proterozoic. And some of those are huge, like the Vredefort one in South Africa, Sudbury one on the shield of southern shield of Canada. Also, there's Archean impact evidence from spherules in thick sedimentary rocks that are widespread in like South Africa. And these are estimated to be impacts of impactors that are 10 to 100 kilometers in diameter. This is in the Archean. And so to me, that'd be early flood In the early flood, you had a lot of impacting and rifting and a lot of pulverizing of sediments to form the sediments on the continents by the peak of the flood that ran off later in the flood. I think impacting is the only way you can create all this huge amount of sediments, and it's fine-grained sediments too. It's not conglomerates. So it's been pulverized and turbulent mixing to decrease the particle size. Anyway, I am a big fan of impacting, but I also believe in catastrophic plate tectonics, more like midway in the flood. So the summary of the major questions: the water comes from impacts and volcanism. Valley networks from overland flow and even groundwater. See, for groundwater, you got to recharge it from precipitation still. So it's all from precipitation, especially when the valley networks a lot of times start on high terrain and disappear into the lower terrain. Need around 100 meters of gel, which is easily conceivable from multiple impacts. The outflow channels are from a breached lake in Valles Marineris, and the water end up back into the surface or in hydrated minerals. That's the end. And because I couldn't modify this for some reason, whoever controls PowerPoint said won't let me modify anything. So I end up with one of my books that is semi-related. Anyway, I'm open for questions now.
Thank you, Mike. Again, comprehensive presentation. The Missoula Flood Controversy. We've done a presentation with you here on that one, and we had a thorough Q&A as well. And so, Mike, if you wanted to make your way back to the stream, at least the studio, and then you can see some of these questions that come in.
Okay, I got to. I must be back, right?
Yeah, there you go. I can see you. So again, great presentation. I find it fascinating that, and correct me if I'm wrong, if I'm understanding it correctly, basically secular scientists agree and confess that there's evidence that Mars experienced a worldwide flood in the past, but there's no water on Mars. And they're hypothesizing reasons why that happened, where the water went. But on Earth, we have plenty of water. More than 90% of the Earth is covered in water, but yet they will reject a global flood on a planet where we have more than enough water.
Oh, yeah, right. Just have to change the bottom and top some and they cause a flood easy.
Yeah. But then on Mars, there's no evidence for water, but yet they'll admit that at some point in the past, there was a worldwide flood.
Well, it'd be more of a multiple large regional floods.
And then and your hypothesis is suggesting, with the cratering hypothesis, day 4, that this occurred in a short amount of time during the Genesis flood time period, rather than over millions to billions of years, like the secularists would argue.
Yes. Mm-hmm. So all that water was available all at once, or nearly all at once, in a matter of weeks, days, months, maybe a few years.
Would you consider that supporting evidence for your specific flood model that focuses highly on these meteor impacts during the flood, Mike?
Oh, yes. Yeah, I started off being curious about, is there evidence for these floods on a planet that has no liquid water? And indeed, there's some fantastic features of floods, like I've seen in the Channel Scatlands. And so that led me to do this research project and kind of accidentally realized that impacts will do it. And if impacts hit Mars, cause the floods, about the time of the Genesis flood, well, that would be indirect evidence that impacts were part of the Genesis flood too. Maybe it caused it. And Maybe it was part of catastrophic plate tectonics. I'm still gelling those things over in my mind of how they relate.
And you were saying that many of the features, the geologic features on Mars, Mike, they're very similar to the features that we see in the Lake Missoula flood.
Yes, the outflow channels, especially, which are those are the big floods compared to the valley networks, which are little floods.
So on Mars, these are more widespread, and then the Missoula flood is a massive regional flood.
Yes, right.
But those features on Mars are more widespread than we'd see with the Missoula flood.
Yes. Cassie Vallis. Oh no, I got the wrong. Okay, that's the one. That huge one, that's the one that implies 10 to 100 times the volume of the Lake Missoula flood. But the other ones are smaller outflow channels, floods, various sizes. So, what was your original question? I kind of lost track.
Well, I guess it comes back to this idea that we can look to Mars, we can look at the geological features that many in the secular world argue are there because of many large regional floods.
Yes.
We can get an idea as to how the worldwide flood happened on this planet and
Yes.
shape Earth's features. Okay.
Yes, impacts are must be a significant part, especially when we have evidence for 200 of them now, and some of them are very large, and some are way back in the Precambrian. So, yeah, this has a lot to say about a flood model. So, yes, I think it's very important for understanding the flood and what the flood did better than we do now.
Do you believe any of these impacts occurred during creation week or in the pre-flood world before the flood, Mike?
I do not.
Okay.
Because, well, if they occurred after day 3 or day 4, when Faulkner would put a lot of them on other places, it destroyed the Earth, killed life. Definitely not between the creation and the flood, because some of them are so powerful. In fact, there's studies that indicate the Vredefort and the Sudbury impact. Sudbury's they've concluded about 200 kilometer diameter crater, Vredefort 250 kilometers, and those would probably destroy the surface of the Earth by a surprising feature that you wouldn't expect. Not necessarily the fireball that would probably destroy 10% of the Earth, but by the impact debris that goes out above the atmosphere and is sucked back in. And as it's coming back in, it heats up to 1,600 degrees centigrade and radiates up and down, infrared radiation. And that goes down will start global wildfires. So those are so powerful. And then the Archean impacts, which are just same size, they estimate at least 10 of those. The combination is so powerful it destroy the Earth between creation and the flood. So I've heard those that try to distance themselves from impacts. Yeah, we have creation. It's controversial within creation science. They try to put it on day 2. I mean, why would God blast the Earth with impacts, those large Archean and Proterozoic impacts on day 2? I mean, on day 3, it started killing organisms, but day 2, there's no organisms to kill yet. But the Earth is still underwater, And is it the same? Is it really the planet Earth before day 3 or not? I mean, to me, it's just not a very satisfactory place to put impacts. But placing them early in the flood uh, is a good choice, I think, because it could solve a lot of features. First of all, we need to generate a huge amount of sediments. By our flood sediment research project, we're finding out that at the peak of the flood, about day 150, the average sediment thickness on the continents was close to 4,000 meters. That had to come from somewhere. And then the top 2,000 meters was eroded off during the recessional stage, leaving about 2,000 meters still on the continents. So you have to generate that sediments in 150 days, and they're fine particles. Sand is the coarsest particle. Then there's a lot of silt and clay shape features, as well as chemical sediments like carbonates. So you got to pulverize that sediments. So impacts with huge turbulence and current speeds could do it. And you got to form the great unconformity on all the continents. That's where you scour down the upper crust down to generally a planation surface. It's the Canadian Shield is part of the great unconformity. You can see it in the bottom of the Grand Canyon, but it's in the top of the mountains in Montana and Wyoming, where I live. And it's on all continents, even Antarctica, where some of that the mountains have risen up, and you see flat top mountains. So you got, and that causes to form a planation surface of that immense size and generate all that sediment. You need powerful currents with huge turbulence. Impacting will do it, and also create other unconformities. You see a lot of angular unconformities where the sediment's tilted like that, and then sediment on top of it's flat, it's sheared off and it's flat, a lot of things like that. And all the impacting would cause a lot of deformation and movement of the crust. So impacting could do it. I don't think catastrophic plate tectonics at the beginning of the flood can produce a lot of the features we see in the sediments of the earth. So impacting will actually explain a lot of different things.
Those are some great points. It makes a lot of sense. So having one major cratering event during the flood, as you're proposing,
yes,
can be a major factor in generating the massive amounts of sediments that we see on the planet.
Yes. And also creating the great unconformity by powerful currents that erode, scour the upper crust generally flat. I say generally flat because there's erosional remnants on the upper crust, like in Kansas. Below that, we've been mapping these surfaces, and in Kansas, a couple thousand feet below the sediments, you got the upper crust, and you find nice sharp erosional remnants, kind of like the shape of Devil's Tower, coming up from the upper crust. These are erosional remnants, and those had to been formed fast, because if it was slow, over millions of years that would erode away, because vertical or steep slopes erode much faster than horizontal surfaces. So you shouldn't have anything like that over millions of years, but it indicates a rapid scouring, leaving erosional remnants, which practically all floods leave erosional remnants. So it all makes sense.
Mm-hmm. So those that would reject this major event during the flood period and put these craters, I guess, being formed during the creation week, day 2, I think you said.
Yeah, day 2.
So right there, they would have a missed opportunity to explain a lot of these sediments, because they're rather than putting them during the flood, they're choosing to put them during the creation week instead.
Yeah, and yeah, the Archean ones are of interest because they're in a formation in South Africa that's pretty large scale and about 10 kilometers thick of volcanism and sediments. So what caused that on day 2? I mean, it produces so many questions. Why would God do that in his creation? It makes to me, it makes no sense. Pardon me for those creation scientists that are listening that don't quite agree.
Hey, there's nothing wrong with healthy debate and healthy disagreement within creationists, and it's important to have multiple working hypotheses.
I totally agree. Yeah.
So I was wondering, because I've seen some in the creation world, they've put forth an alternative hypothesis. And if I remember correctly, I think they'll say that all of these crater impacts, they might not really be impacts from meteorites, that they might be due to underground volcanoes.
Yeah, Mars.
Mars. So, no pun intended there, since we're focusing on Mars today.
Yes, it's spelled different, MAAR.
Right. Yeah. And the extra A. So from Mars. And so they're not really from meteor. I'm curious what your thoughts are on that hypothesis, Mike.
Well, I don't think too many of them are from volcanoes, because volcanoes usually pile up cones, and Mars volcanoes usually caused by hot water. And so some of these craters are so huge, I don't think you can explain it by heating up any water from the inside. I think the heating of the water is done by accelerated radiometric decay. Also, just the shape you have, it conforms to what we expect from an impact. When you form a transient crater, and then that starts to widen by the sides sloughing in and the center moving up, forming the central uplift, or if it's not just one point, if it's multiple large areas, called a central uplift. Anyway, it's a large area that's uplift. But that's what you expect from a crater, but not a volcano that goes off because of heated water and doesn't form a cone. We have these on Earth. You can compare them. A lot of times they have lakes in them where it's wet. So I think there's quite a difference between volcanism and impacts. So I don't go along with that these are effects of volcanoes.
Yeah, those are some interesting points, because you'd have a volcanic crater, like you're saying, which would originate from underground, and then a crater from a meteor from space.
Material out.
And so there would be enough differences to tell which is which.
Yeah, I think there's a lot of differences. Okay, yeah, I know about that idea though, and I just don't buy it.
Mm-hmm. Do you think some could be?
Oh, I'm sure it's possible.
I guess you'd probably have to study each one on a case-to-case basis and compare.
Yeah, and some craters don't necessarily have volcanic peaks in the middle. It depends on it's like a fluid. When it comes up, it's solid, but it acts like a fluid. It comes up, and then sometimes it goes down, and it can go back up again. And sometimes it can freeze, as they call it, down low. Some on the moon are like that, where you'd expect a peak in the middle, but there isn't anyone. And as a result, they have a high gravity anomaly and are called mass guns. And it's interesting that high gravity should have relaxed by now if they were billions of years old. So there's a number of features in the solar system that indicate it's a lot younger than they think.
Mike, you mentioned the generation of these sediments and how the impact crater hypothesis that you propose can really help in explaining all of these sediments and their accumulation. And so my question is, proponents of catastrophic plate tectonics, how do they explain the generation of all these sediments? Do they look to just massive tsunamis worldwide during that time period to generate them?
That's one that's promulgated by Dr. John Baumgartner. I do have problems with that idea because he has to generate the sediments from the continental margin that's spread up over the continents in a tsunami. But then tsunamis have a backwash coming back. And I am kind of hard pressed to see thick sediments on the continents that show features like these. It seems to me to be hard to generate. He does it by cavitation. And cavitation, you need very strong currents in shallow water. And I'm not sure that's sufficient enough to generate much sediments. But he's working on it. He's modeling it. I think that's the wrong place to look. Besides, catastrophic plate tectonics doesn't start. There's a starting time with it because a lot of before the Atlantic opened up, a huge amount of geological activity had already occurred. For instance, there's some huge precipitates, the largest in the world, in the South Atlantic off Brazil and its conjugate in Africa. And then this is why I accepted catastrophic plate tectonics only several months ago, because I find a lot of problems with it. It's because it has a rare precipitate. It's not an evaporate, because if it gets into air, it dissolves. It's called tachyhydrite. No one's probably heard of it, but it's a rare one. It's found only in 3 locations. 2 of them are in Brazil, I should say the northern part off the coast and along the coast, and its conjugate off Gabon and the Congo. And it's about 100 meters thick of this rare precipitate. They call them evaporites, which they can't be. And the only way that can be is if they were connected and the Atlantic spread. But in this one basin where you find it in Brazil, you also have 9 kilometers of sediment below it generated in this basin that's partly onshore and partly offshore, Sergipe Basin, meaning when the Atlantic split, we had 9 kilometers of sediment already fill up that basin. And so there's a lot of possibilities. Various creation scientists have a lot of ideas. Some of them believe that there was 2 splits, Rodinia or Panodia, that split and then came back to form Pangea that split. Now, the catastrophic plate tectonics mechanism is a mechanism to split. What mechanism would cause it to stop, those continents to stop, accelerate back, crash back in,
right,
and then split again? I just don't buy that. And so I think that this is a mid-flood phenomenon that continued late in the flood. And so that's kind of why I'm thinking that maybe impacts were the main mechanism of the flood. I just came to this in the last month or two. The logic of it would tell me that impacts came first, generated a huge amount of sediments, and maybe caused catastrophic plate tectonics where the Atlantic opened up. So this is controversial. I'm going to get a lot of
controversy is fun though. That's good.
Well, yeah, as long as we can do it in charity.
Right. Exactly. As long as we can do it in charity. And so these impacts, these meteorite impacts in this cratering model or theory, Mike,
Mhm.
the impacts would be distributed worldwide quite evenly during the flood, rather than just all being in one place and bombarding a specific spot.
I think they probably occurred quickly, and because the Earth turns in 24 hours versus the Moon in 28 days, the impacts were more random
Okay.
than in the Moon on one side. So I think, yeah, they're more random.
Okay, so
Um,
that's why they look more random on Earth, but with the moon, they're kind of
yeah, they were mainly
situated
on
or
one
localized.
side because it was quick. So I see a quick impacting that exponentially fell off during the flood with a few remnants after the flood, like Meteor Crater in Arizona, which is a post-flood crater.
Since it's more random then and distributed worldwide randomly, would that reduce the amount of heat and energy produced from all of those impact craters in such a short amount of time, Mike?
No, I don't think so. Each
Mm,
each one would have its own kinetic energy, and the big ones would still blast a lot of material out above the atmosphere that comes back
right.
and heats up to 1,600 degrees centigrade, radiates, causing global wildfires. It would, uh, yeah, because it spreads out over the Earth, whether it's random or not. It'll spread out, and then the heat of the infrared radiation coming from these accelerated particles being accelerated down to the Earth would start global wildfires. So we'd easily destroy the Earth, but the Earth was being destroyed by the flood.
Right.
So yeah, I mean, it fits so well,
Mhm.
I
Okay,
think.
so this was just another factor in God's universal judgment on the earth. So it was not
Yes,
only a geological event, it was also a cosmic event.
yes, a cosmic event, and a few other features. It can also produce 40 days and 40 nights of rain
Mm,
because when impacts hit the ocean, what are they going to do?
right.
Blast water up that'll
Yeah.
spread by the upper wind all over and come down torrentially globally. So, and this is an idea not for me, but Wayne Spencer. He presented this at an international conference on creationism, I think in 1998. And it's a great idea. And we can account for that by impacts. Like I said, impacts can cause potentially explain a lot of features that are very difficult to explain by catastrophic plate tectonics and other ideas. And I'm getting some ideas on where did the sediments originate? Well, it looks like informing the great unconformity, the sediments were probably, as far as North America goes, on North America. So we pulverized a lot of that sediment. Um, and the evidence that a lot of it came from the continent itself, not off the continent. I once thought it was probably had to come from the ocean, but changed my mind. Um, is because I talked about the Sudbury impact crater in southern Ontario, where near where
Yes.
you live,
Yes, very close. Sudbury. Yeah, been there.
and the Vredefort one in South Africa. These are erosional remnants. It's believed that you eroded 5 kilometers of sediment over the Sudbury impact and 9 kilometers over Vredefort. What is that telling us? That we had a lot of material on top of the great unconformity that's no longer there. And that's probably enough material to probably account for all the sedimentary rocks on North America and probably all the continents. So
So
I
you
think
I'm sorry, go ahead, Mike.
I'll finish the thought. So I think the sediment came, especially from the Canadian Shield and the great unconformity that is actually in the United States in areas.
That's very good. And you mentioned several interesting points. I want to backtrack a little bit because you mentioned worldwide wildfires, I think, due to a lot of these impacts. And
Yeah.
it kind of it brought to mind an objection or a challenge that I've heard recently that I found interesting, and I wanted to get your thoughts on. And so basically, if I could reiterate this challenge that the old earthers or many in the theistic evolutionists can't put forth to the global flood, they'll say, excuse me, they'll say that we find an abundance of charcoal in several different sedimentary rocks around the world,
Hmm.
Mike.
Yeah, we do.
And so their argument is basically, yeah. So they basically say, well, if these rock layers were formed by the flood, then we shouldn't find all of this charcoal because fires that burn forests would not be expected, they say, would not be expected to occur in the midst of 40 days and 40 nights of rain. And so what would be a good response to that, Mike?
Well, that's a good question. There could be maybe it wasn't continuous, but rain. Um, and maybe with the impacting that you had you'd have the wildfire start within a matter of probably a day or so. So you could have had the wildfire start forming charcoal um, early on. So there's possibilities, but it is a good question and a possible conundrum.
So we would have some ideas for it.
Yeah, I think so. I just actually hadn't thought of it. There's so many aspects to all this stuff
Right.
that and I don't think this is figuring out the flood is one person endeavor. It's going to take a multiple teams of us um, putting our heads together, and someone's better in some areas than others, and it should be a multidisciplinary, multi-scientific research project.
That's right.
Yeah.
And it's nice having a team or community as well of researchers because firstly, I feel blessed to have someone like you who's researching these topics related to flood geology. Because while you're
Mhm.
doing that, I can focus on genetics and biology related topics.
Oh yeah,
And then other researchers can focus on astronomy or
right.
focus on physics. So there's so many different fields and so many
Yes.
a strong necessity, I guess, for so many different researchers. And so, Mike, here's another one that skeptics like to point to. And so skeptics assert that we should find mega ripples. We do find these mega ripples on Mars, right, Mike?
I don't think you find many ripples on Mars.
Okay. Okay, so that's interesting then, because their challenge is we should find mega ripples on every continent on the Earth if there was a worldwide flood. They say mega ripples only happen when glacial lakes break. What would be a good response to that, in your opinion?
You do find ripple marks on gravel bars in the Lake Missoula flood path, about 100 of them. You find nice ripples on Camas Prairie. Um, I don't think you. I don't think you don't find them with the Genesis flood, and maybe it's because it's so large and so powerful. Probably a lot faster currents than the Lake Missoula flood, which are up to 60, 80 miles an hour, I might add. You don't find many gravel bars either, but I have found some in certain areas in Montana to the north of where I live, um, where it was kind of a slack water area where the water would be ponded as it was draining towards the west. And because of certain water gaps and water coming through those gaps, which are 2,000 feet deep, I might add, carved by the channelized phase of the flood, you had convergence of the water, and you did form gravel bars. And there's, I think, a gravel bars another one other location I found in Montana. So you find them, but not like you do in the Lake Missoula flood. But I think it's just because it was just so much larger and powerful. It just eroded everything out, and for some reason, I don't know the hydraulics behind it, but that's a good question. You don't find these ripples, or
So are they
maybe you
basically,
do, and I just have missed them.
are they basically saying, okay, a large regional flood like the Missoula flood, which nobody would argue with, and we as young Earth creationists, we can look to that flood and give us an
Mhm.
idea into how the worldwide flood would look in
Yes,
terms of its geology. And so you were saying in the Missoula flood, we do find mega ripples.
only on gravel bars,
Okay. Okay.
and you don't find many gravel bars uh, with the Genesis flood. First of all, the gravel is pulverized,
Mm-hmm.
so and it was very erosive as it ran off, and so other than the gravel bars, you don't find ripples in. As far as I know, I can't recall any ripple marks on the floods of Mars,
I quickly
and
I quickly
those are
looked it up, and I mean, it's the first source that came up. They say mega mega ripples are distinct wind-driven formations that occur on the surface of Earth and Mars, but it doesn't say how many on the surface. Is that the same thing that they're talking about, or something different?
well, yeah, there are wind ripples on Mars, lots of them, but those are from the wind.
Right. This one's from glacial lake breaks, which would be a little different.
Yeah, this is from water.
Yeah.
I don't, as far as I know, I don't think you find any water ripples, which would probably be good size. But you find a lot of wind ripples, and you
Okay.
have moving dunes in places on Mars, which is rather a surprise because the atmosphere is only 6 millibars.
Mhm. So are they making an assumption that what we find in these local regional floods like Lake Missoula, those would be the same conditions, the exact same conditions as a worldwide flood, which would be a lot more intense? I think you hinted at, Mike.
I think it's the Lake Missoula flood is a partial analog, not a perfect analog, and
Yeah, I
there's
like
I think could be the difference. The larger floods, I would speculate, didn't leave ripples and didn't leave too many gravel bars because there wasn't much gravel to be left, except in very local areas, which I have found here in Montana in two different locations.
yeah,
Um,
that makes sense to me. Okay, Mike. So here's one that comes in from Brute Facts Podcast.
okay,
Appreciate the support for to this evening's show. As always with you, Mike, very informative. And I like the fact that you're willing to engage the tough questions, the challenges. You and I,
mhm.
we like to talk about how easy it is to refute and counter evolution in many ways. So it's good to focus on the challenges to our position rather than
Mhm.
ignoring them. Let's take them on head on.
Oh, I don't
And
ignore them. I think I look at them as challenges.
yeah, fun challenges too, because when you find an answer, like your bed's hypothesis,
Yeah.
when that came to you, that's exciting. It's like a light bulb going off, and you think,
Yes.
okay, yeah, we have an explanation for this. So hear from Brute Facts Podcast, an objection he's heard. So again, thanks for the question, thanks for the support. He says,
Thank you.
if the flood was global, it would have to cover the mountains. How did they not freeze to death or die from lack of O2?
Okay. That's what an atmospheric scientist like me can answer, and
Right.
it's actually a pretty easy answer. First of all, the flood did not have to cover the present high mountains, which is an impossibility. In fact, read Psalm 104, verses 6 to 9. That refers to the flood, where it says in verse 6 that God covered the earth. He covered the mountains. Now, this is not day 3 where the dry land appeared, because that's an uncovering. But this covering has to refer to the flood. And then he set a boundary where the water cannot pass over anymore. So Psalm 104, 6 to 9 is referring to the flood. And verse 8, in many translations, which are, I believe, the better translation, is it says that the mountains rose, the valleys sank down, and the water ended up the place where God had placed it, mainly the oceans. Well, we see evidence of vertical tectonics, mountains that rose, even adjacent to valleys that sank, all through the Rocky Mountains. This is a signature. So that's telling us that, like the Himalayas, they didn't have to be covered. They were sedimentary rock, and then they come up late in the flood, and a lot of erosion from them until they penetrated into the air, and then the erosion stopped. So you don't have to cover the mountains. And regardless of what level the water is, you're always going to have the same pressure and oxygen. It's going to be 1,013 millibars, which is the average sea level pressure. Whatever altitude the floodwaters are. So the oxygen. So it's not, you're not going to freeze to death. In fact, the water would be so warm, and by the contact of warm water with the air would warm the air. Also, as you evaporate from the ocean, you cool the ocean, but add latent heat to the air, that when it condenses, you add that heat. So even during the flood, you couldn't, there wouldn't be any freezing temperatures. It'd be very warm temperatures, actually.
Right.
And that would be one of the keys for the ice age afterwards, the warm ocean, because the warmer the water, the more the evaporation. So
Two
thanks for
excellent
that.
answers. And it is right there, two common challenges, and you address them perfectly. So basically, the mountains we see today, they didn't arise until late in the flood, and
Yes.
therefore, would you say the pre-flood, quote unquote, mountains would be more comparable to high hills?
Oh, yeah, that's what I lean towards, and I think
Mm-hmm.
practically every creation scientist leans that way. But even if you had some high mountains, the catastrophism of the flood would pulverize them, and impact hitting
Right.
it, volcanism, strong currents.
Mm-hmm.
So even if you did have some high mountains here or there, they would get pulverized. But we lean that the mountains which did exist before the flood, were lower.
So we know, and I'm curious, Mike, we know according to catastrophic plate tectonics, basically the earth fractured like an eggshell, and you got these continents moving
Mm-hmm.
from, I think you mentioned a Rodinia like starting point rather than a
Some
Pangea.
think Rodinia, that came back together to Pangea, then split. That's one idea. Others think of Tenodia that did something similar to that.
Mm-hmm.
And then Tim Clary believes that we only had one splitting, which makes more sense. But he calls it some kind of Pangea-like continent. But it starts. No, he has a crashing back too, because he has the Atlantic Ocean actually starts 300 to 500 kilometers wide, and has to come back, forming the Appalachians and the Caledonian Mountains in Europe, Appalachians in eastern North America, and then split. Anytime you're in the model, when you bring plates back, I don't see the physics or geophysics behind any of that. I don't think that really works. So they're we're kind of stuck with one splitting, and from what all we can see, that was a mid flood to late flood event, not an early flood event.
Okay, so according to your model, there wouldn't be. So there would be continental sprint and plates moving to
Yes.
crash into each other and form these mountains, but not as much as CPT would suggest, Mike.
I haven't gone that far as the mountains, because some
Mm.
mountains are not at plate boundaries. And and other things. I've been studying catastrophic plate tectonics and plate tectonics for 40 years, and they have ideas on how mountains, especially volcanoes, form. But tomography is like sending multiple probes through the earth, and you pick up various features. And these tomography, there's a lot of things people don't know about them. When you see a nice subduction zone that's supposed to be colder, a colder slab, in many models, that's an initial condition. And when you get rid of that initial condition, it doesn't show up too well. It you see it shows up partially. But the interesting thing about it is that you have a slanting subduction zone underneath the mantle, which is called the mantle wedge, and then you have the arc volcanoes going off. The tomography, seismic tomography, shows that the low velocity areas, which would be partial melt, actually don't come from the cold slabs from about 100 kilometers. They mainly come from way deep down in the mantle, 400, 500 kilometers deep, and they come up at a slant. Um, Hardly any creationists even know about this, but it's plain as day on practically every cross section across the seismic subduction zone. So their ideas of how volcanoes form, I think, is flawed. I'm finding that out. And like I said, some mountain ranges aren't near plate boundaries, like the Transantarctic Mountains.
Mm.
But in some cases, I think, plates crashing can form mountains. So it's probably a variety of processes, and we can't just focus in on one thing, because there's glitches
Right.
I have found in the seismic tomography images, cross sections, especially that is questionable for the forming some mountains, especially volcanic mountains.
It's multi-dimensional. It's not just a one size fits all. And I
Yes.
can't remember all the details of this because I was engaging this issue a few years ago, and there were critics of the global flood, and they pointed to, I think it was stratified fold-in mountain ranges between divergent plates. And that was a challenge that I remember researching, and I think it might have been Dr. Andrew Snelling suggested an explanation for that based on is what you're pointing to, where you have temporary supercontinent like Pangea during the flood that comes together and then breaks apart again, which would explain those mountain ranges. Does that make sense, Mike?
Oh, if that happened, but I don't think the physics will cause any plates to first spread, stop, come together, or even start at rest and come together.
Right.
I just don't see the physics on that, and that's where they form a lot of mountain ranges. But as it's splitting, it can crash into barriers and cause mountain ranges.
Okay, so you don't need that temporary supercontinent to explain the various ranges.
No, I don't think so.
Okay.
I don't know how the Appalachians rose. I think they rose. I'm getting the idea. That's part of our research projects in the flood sediment research project. I think the Appalachian, the Blue Ridge area and the Piedmont area, they rose from the mid crust, from very deep. And why they did that, I don't know. But the metamorphic grade of a lot of those rocks in that area would suggest deep uplift. And that kind of uplift would cause a huge amount of potential energy for the sediments on top that would cause a big sloughing off to the northwest that can account for the overthrusts in the Valley and Ridge province. We're John Reed, Peter Kleberg, and I are working on the Appalachians right now.
Oh, that's good.
So that's why these ideas are kind of floating around in my mind.
I don't know where you put all those ideas, Mike. Over the years, all your research, your brain must be overflowing with information and ideas.
I got a huge amount of ideas, and I just can't get them out in the short time I have left.
We need to duplicate you, maybe get another 100 of you, Mike, and we'll be able to tackle multiple research projects at the same time.
Yeah.
So that's great. That's helpful. Your answers there are very helpful, Mike.
Mm-hmm.
And so here's another major one that comes from the critics, and it looks like you're familiar with it. So for the audience sake, critics of young Earth creation, they argue that worldwide floods, so a major worldwide flood, in Genesis, can't explain clean, pure sandstones like the St. Peterson sandstone. They point out that only rivers and beaches can create pure sandstones. Mike, what would be a good response to that?
First of all, I'd ask the critic, do you have evidence for that? Actually, rivers and beaches don't produce clean sandstones. You're talking about quartz arenite, which is a sandstone, which is about 25% of sandstones, I might add, that is almost pure quartz and well-rounded grains. And as far as we know, those things, both of those aren't, it's called textural maturity and mineralogical maturity. Neither, both together, as far as we know, are not forming anywhere on the Earth. Check the literature. I have an article that just came out in the journal Creation, I think, on that you can get online. Anyway, we're in tropical high precipitation areas like the Amazon and the Congo. You can actually form mineralogical maturity. In other words, the weathering will weather the feldspars out from granite and some of the large, the black minerals, leaving just quartz. The problem is you got to round it. And there's the problem. And for those areas. Now, the Congo River has a lot of sand that would, if it was lithified, would be called quartz arenite. But there's a lot of quartz aranite formations in the Congo that are being eroded, that are forming it. So that's where that is from. Those otherwise on South America, you're getting a lot of quartz in the rivers and the deltas, but no or hardly any rounded quartz. But when you look at the rock record, quartz aranite is very abundant in the Precambrian and decreases up through the Paleozoic, and they have very few in the Mesozoic and Cenozoic. So the Precambrian and the Paleozoic are for sure early flood deposits. So I believe the only way you can form huge deposit, and by the way, these quartz aranites, some of them are over 100,000 square kilometers, and some places over 1,000 meters thick. How are you going to form that with uniformitarianism, present processes over millions of years? It's not demonstrated to occur today. Rivers, beaches, whatever. But we can account for it in the flood. By early flood, I believe there was huge turbulence, probably caused by impacts. The turbulence and probably the acidic waters would dissolve most of the other minerals and leave quartz. and the powerful turbulence would round the grains. It's been speculated, but not shown, that by secular scientists that present day water won't round them, but wind will round them, but wind won't produce mineralogical maturity. In other words, all quartz. It's very rare if it happens at all. But the powerful turbulence in the flood and the floodwaters probably being acidic in a lot of areas and hot, would form the quartz and round the quartz. So early in the flood, you'd have a lot of quartz arenite. Quartz aranite, it would be the sand that becomes a sandstone, and most of it is cemented by quartz, silica. And to do that, you have to have temperatures usually over 70 degrees centigrade and a lot of overburden to press the particles closer together, and the fluid coming in with the silica to cement it. So it's cemented by silica, the same material in the particles, the grain particles. So I believe the flood is the only way you can form those massive amounts of quartz aranite that we see in the sedimentary record. That is in the earliest the oldest sediments, the Precambrian and the Paleozoic.
Okay, that's a great answer. That's a thorough answer. So basically, the powerful turbulence during the flood, the flood-related conditions,
Yes.
would rapidly form this quartz.
Yeah, form the quartz and round it.
Okay. And you were pointing out that the uniformitarian model would have a more difficult time explaining what they put forth as a challenge to us.
Yes, because the currents are, first of all, too slow and not turbulent enough to do this rounding. Because, I mean, there's been a lot of research off Namibia coast, if I pronounced it right, off at southwest Africa, where the water of the Orange River spreads sand, and the sand is spread northward for about maybe 2,000 kilometers. And so because it's so dry there, you're not chemically weathering the particles. So you have a lot of other particles besides quartz. And then the river and the flow along the beach does not round them. It's not strong enough. And tumblers, they've done experiments with tumblers. Philip Coonan showed this, that it's slow water and low turbulence doesn't do much for forming high quartz rounded grains in the sand.
That's a great response. So, and I've heard many put forth this as a major challenge, but you've provided a sufficient answer, I would say, to.
And I just published that on the Journal of Creation. It's either just published or will come out in the next issue. I haven't looked at my latest issues to find out.
You've written so much, and that's good. That means you're getting articles published all the time, which we can be blessed by as you engage these challenges. And then you also mentioned the temperature aspect as well in that point of the sandstones, right? 70 degrees.
Yeah, you got to form the quartz fluids, silica. You got to dissolve it from somewhere and move it by the fluid to become the cement. Because you got to cement the sand, and it might a sandstone might be 20 to 30% cement. So that's a lot of fluid, and a lot of quartz, and quartz becomes more soluble above 70 degrees centigrade, exponentially more soluble. So the hotter the sediments, the more you're going to have some quartz in the fluid, dissolved silica.
And we know, as you pointed out earlier, that the Earth in general would have been very warm, very hot during the flood year.
Yes, it would have been.
Okay. Well, I appreciate that, Mike. Here's a follow-up question from Brute Facts Podcast. He sent in the question earlier about the mountains and
Okay,
the
I
CO2.
remember.
And so he just wants to clarify, just to make sure I understood him. Though evaporation, or so through, I think, through evaporation on the surface of the waters may have a cooling effect, as the vapor rises and cools and condenses, it warms the atmosphere.
Correct. Um, Evaporation, it takes a lot of heat to cause these changes of phase. For instance, it takes 540 calories per gram. That's a lot of heat to cause the evaporation of 1 gram of water. And then when it condenses, that heat goes back into the atmosphere, goes into the atmosphere. That's called latent heat. And so that's right. So during evaporation, you cool the ocean water, you cool the water, and then the water vapor, when it condenses, warms the atmosphere. In fact, in my ice age model, 3/4 of the ocean cooling after the flood was due to evaporation, and about 1/4 due to contact between cold air and warm water. So 3/4 of the cooling of the ocean during the ice age was from evaporation, which adds the water vapor you need for the ice, as well as the heavy rain in areas not glaciated.
Is that how the secularist explains the massive salt deposits that we find on the earth through evaporation, Mike?
They try to do that. They call them evaporites as a result. But when you look at these things, like the quartz aeronite deposits, some of these things are huge and pure. Like the bottom of the Mediterranean Sea and some of the areas where the land is risen up, you have a layer about a kilometer thick of they call them evaporites, starting with gypsum and then coming to salt. Those are the two main so-called evaporites. They're about over 1 million square kilometers. And by the way, that occurred in the late Miocene, which very late in their scheme. So how that ever happened? And to evaporate, let's see, to evaporate the Mediterranean Sea, all that water, you would have 60 meters of vaporites. And so you'd have to vaporize the Mediterranean Sea over a dozen times to produce that. But some of these salt layers are very thick, a lot thicker than a kilometer, like the ones off in the South Atlantic are off the coast of the Congo. It's up to 4 kilometers thick. So I don't think that model actually works. We have two models out. One is the Steph's Herima's
Yes.
igneous salt model, which you're probably familiar with. I'm kind of leaning away from that because of the characteristics of a lot of these salts. And I kind of lean that as some kind of precipitate, where it actually precipitated out of the water. A number of creation scientists lean this way. That's one area that we need good research, and I would like to do it if I had more time. The conditions to have rapid formation of salt out of the water, you have to have, it's called supercritical water. What conditions you need supercritical water? Well, you need a temperature of about 400 degrees centigrade and at a depth of about 2,800 meters in water. Tall order, but the results of an impact crater that caused a deep crater that with hot walls could potentially do it. Anyway, that's a speculation I've had on my part for a long time.
No, that's good. So when it comes to these thick salt deposits,
Yeah.
if creationists were forced to explain the evaporites through evaporation, then we would have a challenge. But you're saying there's other ways to form these thick salt deposits, Mike?
Yes. And I think they have more of a challenge. The one in the Mediterranean supposedly only took place in 500,000 years deposit, and so you'd have to vaporize the Mediterranean Sea over a dozen times, and so so they have all these scenarios where
Mhm.
the Strait of Gibraltar rose up and blocked the Atlantic Ocean, and a lot of stuff like this, tectonic uplift there. But it's pretty far fetched. Then you gotta lower it, and then you gotta fill it up again. It becomes pretty stretched model, I believe, to account for them that way. And the ones in the South Atlantic, those are actually large. The largest so-called evaporate in the world are the ones in the South Atlantic on both coasts. Um, so it's and a lot of them are in deep basins along and all, at the edge and the barely onto the continents. Eh, So they're mostly offshore. And by the way, they have a massive amount of oil, and so that's why they know a lot about them. And I'm thinking that oil and so-called evaporites, those can be connected to impacts, uh, but not too much of a stretch of the imagination.
Mhm. Well, there's
Like I
another
say,
explanation through the impact hypothesis that
yeah, like I was saying, we have the potential with these impacts to explain a lot of features of the Earth. I mean, the questions included quartz arenite, uh, so-called evaporites. So and yeah, lots of potential. I've just started to scratch the surface.
yeah, I love it. I love all the research you're doing. So rather than through evaporation, you were saying that these evaporites could be created through precipitation.
Yeah, precipitates.
Okay.
In
Yeah. So
fact, some of those rare ones, like tachyhydrite, and also carnallite and bishoite. I'm not pronouncing them exactly right. Those three are very soluble in water to the point where if they actually hit the air, they would disappear. They can't be in air. They can't be formed in air at all. So they have to form in water by some mechanism other than evaporation.
well, it's very interesting. So I guess we'd have to change the name to precipitates then.
Yes,
Evaporates.
I often use precipitates.
Yeah, I like that. Okay, so rather, and I'm not an expert at this, but just to understand, so through evaporation, the water's evaporating and it's leaving behind these minerals.
Yeah, and we do have a lot of places on Earth where that occurs.
Mhm.
Um, like hot areas along the coast, you get a marginal lagoon, and a lot of times you get so much evaporation, you form uh, highly thick brine, and then you form minerals as the water just continues to vaporize. So yeah, we have them, but they're small areas, and they're not very pure deposits because there's a lot of other features that occur. Mud that gets in there, windblown dust, stuff like this. But the so-called evaporites are quite pure.
Well, that's a great topic, and clearly you've done a lot of thinking on that, Mike. And so as we start to wind down, time always flies by with you, Mike, because these are big topics. They're technical
Mhm.
topics, and they require a lot of back and forth discussion. And
Yes.
so this comes in. I wanted to make sure to get these two in, and then we'll start to wrap up here.
Well, Hi, George.
Yeah, so George Bond, he's here in the chat cheering you on, Mike, and he's, as we like to say, our award-winning co-host here at Standing for Truth. And so he's wondering, Mike, from memory, all coal samples, when dated by C14, date to 40 to 60,000 years. But rock dating, where the coal is found, dates to hundreds of millions of years. Doesn't this point to the rock layer dating to be more 40 to 60,000 years?
Well, they date them by different dating methods. And yeah, you date all coal samples have been dated to about that age. And I might say all soft tissue dates, like dinosaur bones and stuff like this, produce dates like that. But carbon-14 only dates to a maximum about 50,000, 55,000 years. Because after that, contamination becomes more of a problem. But you can still get a date to about 80,000 years. But after 80,000 years, you can't get any more detectable carbon-14 by our instruments. That's why carbon-14 in diamonds is so significant.
Right.
And in coal is dated 15 million to 350 million years old. And diamonds a couple billion years old, but they all have carbon-14. And but the rocks are dated by uranium, lead, which give potassium, argon, rubidium, strontium. Mainly, those are the big three. And they have half-lives of near a billion years, usually more. And so as a result, they give huge dates. And so they date the rock layers by that, but not directly, usually indirectly if it's sediments. They date a igneous intrusion and go from there, and then estimate the date of the sediments. Is how they usually do it. So yeah, there's quite a contradiction in that, and it's we believe that all these dates that give millions and billions of years are due to accelerated radiometric decay, which has some powerful evidence in support of it, like the decay of uranium lead decay in zircon crystals that Dr. Russ Humphreys has worked on. Solid evidence, but yet skeptics always try to criticize it and knock it down some way. But Humphreys is pretty able to answer those challenges, which he has done in the creation science literature.
I heard an old Earth nuclear engineer recently, because we did a talk on helium recently in zircon crystals. And so this old Earth nuclear engineer, he said, well, because a byproduct of uranium to lead is always going to be, as you're moving through the chain, there's always going to be a little bit of helium released as a result.
Helium atoms.
So he said, I'd be surprised if we didn't find helium in the zircon crystals going back billions of years. And so he's basically almost sounds like he's agreeing with us, but he's saying, hey, we would expect it too. Mike, I'm curious what a good response would be.
You for every atom of uranium that changes to lead, uranium-238 to lead-206, you give off 8 helium nuclei that grab electrons and become helium atoms that are a noble gas. And so, it collects, but it leaks out depending on the size of the zircon crystal. So you got to have the same size. I'm going like this, but these things are really like that. So there's a leak rate, and they'll leak out. And so you'll always find some in there because it's always decaying. But the fact that you have gobs of it in there indicates that it's not leaking very fast. And by the leak rate out of the zircon crystal and the amount that's in there, you have a dating method, and that comes out to around 6,000 years, as a matter of fact.
What a coincidence.
Yeah.
Yeah, no, that's a great response. So it sounds like they're now trying to downplay it. They don't have any good rescue devices or responses. So now they have to say, well, I'd be surprised if there wasn't any helium. But as you pointed out, no, we find an abundance of helium, not
Yes.
just a little bit as a byproduct.
Yeah.
But so is the reason why we would conclude accelerated decay because, okay, it looks like there's been a lot of decay from uranium to lead, but wait a minute, we still find all of this helium, which should have dissipated into the atmosphere if these zircon crystals were billions of years old. So
Yes.
there must have been a lot of decay, but quickly to retain that helium, basically.
Exactly. And that can be answered by accelerated radiometric decay within the past 6,000 years.
Interesting.
Very solid result. It's reinforced by pleochoric halo research. Yeah, by that, the Snelling's research. You can find it all in the rate book, which is, I believe, online now.
Yeah.
And very detailed.
Yeah, I haven't seen any good responses. And with the C14 and diamonds you were just talking about, weren't those results from the rate? I think I remember Dr. Andrew Snelling speaking on this in a lecture. Weren't those validated by a couple secular scientists where they also looked at some diamonds and discovered the same thing?
Yeah, it was Baumgartner was the first one to do it. And then secular scientists have repeated it and found carbon-14 in diamonds. Yes, they've repeated it. They've always found carbon-14 in coal. So we just essentially duplicated what they've found. And they kind of consider that contamination. But I think when you find it in all coal samples, and when they take samples, they try to avoid contamination. In other words, they don't drill through a crack in the coal that you would expect some contamination, you know. So it's a hollow hollow. I can't think of the right adjective.
I think they took a ninth diamond, cut it into 6 equal fragments, and yielded radiocarbon ages from something like 69,000 to 70,500 years or something, like just from one diamond, which supposedly billions of years old.
Yeah, I hadn't heard of that particular research.
Well, I mean, those are all great lines of evidence. The helium and zircon crystals, C14 and diamonds and coal. These samples are supposed to be millions to billions of years old, billions for the diamonds. So, and Mike, you have a whole presentation, I think, on dating methods.
Yes, I do.
Well, maybe in the future we'll have to have a whole show on that, brother. So, okay, well, as always, a very thought-provoking, informative program with you, podcast here. This time on Mars, the Genesis Flood and Evidence. We've had a great chat. We still have a great chat with questions flying in, but I want to respect your time. I know you've been busy, Mike. You've got great endurance. You didn't even break a sweat, and you addressed several of these major challenges, and you were very detailed as well. So, Mike, God bless you and the work you're doing. Let's hand it to you. If you had any final words, final thoughts, anything you wanted to leave me and the audience with as we close things down.
Yes, I'd like to present or something to the skeptics. I'd like to say that we're probably more resilient and have more answers than you think. And we're always finding more. And a lot of times when I do a research project in something, I first of all find that it's a challenge to you skeptics too. And I would ask you to be open-minded on all this. And sometimes you got to dig deep. If you really want the answers to these things, you got to dig deep. And I have found that the Genesis flood and the creation make a huge amount of sense to explain the observable world that we live in.
Amen. Well said. You pointed to a couple tonight. I brought forth pure sandstone salt deposits as 2, and you pointed out many great points that, hey, the secularists have an even bigger bigger
Yes.
challenge.
Mm-hmm.
Okay, well, for those that want to see more from you, Mike, I've got, well, firstly, they can look at endless articles here on creation.com, and including your DVDs and books. And then also here on my website, Michael J. Oard, I'll have to add this one to there as well. And then the last program you did with us, if I remember correctly, was the rapid formation of caves. And so that was an excellent talk as well. And actually, oh, I'm sorry, Mike, were you going to say something?
Yeah, wasn't it on ice cores?
You're right. Yeah. So ice cores, and then the rapid formation of caves must have been before that.
Yeah, I'm losing track. It's
You've done so many.
yeah, I kind of feel bad about that ice core one because when I look back on it, I think it was way too complicated. I probably confused most of your listeners, if not all. It's very detailed, like and all, but there's a way to simplify it, I think, too.
Did you do recently? I remember you saying that you did a ice cores made easy presentation, or maybe you put out an article on it.
I did for the Design Science Association in Portland, and I'm having a book come out on it. Hopefully, a layman-friendly book. Should be out by the end of the year from Creation Ministries International on ice cores.
Well, that'll be great. I'll be one of the first to purchase it. One behind, I've got several of your books behind me, but one specifically behind me that I want to recommend is Biblical Geology 101.
Ah,
So
yes.
that's an excellent book for anybody that wants to. I know a lot of what we discussed today can be technical. And so if you get that book and study that one, it'll help you understand these topics a little better. So, okay, Mike. Well, again, God bless you. I appreciate your time, your presentation, and your information here with our questions. To the audience, thank you so much for tuning in. Hope you enjoyed it as much as I did. Share this content around. Share it to your friends, your family, because the truth is so important. So God bless all. Thanks for tuning in. Standing for Truth is out.